India has a water problem that maps almost perfectly onto its geography. Some regions flood every monsoon. Others, sometimes just a few hundred kilometers away, sit in permanent drought. The rain falls in the wrong places, at the wrong times, and then runs off into the sea before it can be used. For over a century, Indian engineers have proposed the same radical solution. Physically connect the country's rivers. Move water from where there is too much to where there is too little through a giant network of dams, canals, and tunnels spanning the subcontinent. For decades, it stayed a dream. Now, India has started building the first link. A 44,600 crore rupees project, around $5.3 billion, transferring water from the Ken River to the Betwa River across the drought-stricken Bundelkhand region. And the first major dam of this century-old dream is being built in one of the most controversial locations imaginable, straight through the core of a protected tiger reserve. The idea of connecting India's rivers is not new. It is astonishingly old. The first serious proposal dates back to the 1800s, when a British engineer suggested linking rivers for navigation and irrigation. But it took its modern shape under a national perspective plan, identifying dozens of potential links across the Himalayan and peninsular river systems. The logic is simple to state and enormously difficult to execute. Please take a moment to subscribe and like the video. It really helps the channel. Some of India's river basins carry far more water than they can use, dumping the surplus into the ocean each monsoon. Others are chronically short. If you could move the surplus from the wet basins to the dry ones, you could drought-proof huge swaths of the country, generate power, and irrigate millions of hectares of farmland. The problem is that rivers do not want to move. Connecting two river basins means building dams to raise water high enough, then canals and tunnels to carry it across natural watersheds, sometimes lifting water uphill across hundreds of kilometers. The total network, if ever completed, would cost hundreds of billions of dollars and rank among the largest civil engineering undertakings in human history. For decades, it stayed exactly where it started, on paper. Then India picked a place to begin. The first link targets one of India's most water-stressed regions, Bundelkhand. Spread across Madhya Pradesh and Uttar Pradesh, Bundelkhand is defined by drought. Its water scarcity is not an occasional misfortune, but a structural condition. Recurring failed monsoons, falling groundwater, and the familiar sight of villages depending entirely on water tankers. For generations, drought has driven the region's young people to migrate elsewhere in search of work. It is one of the poorest, most water-desperate regions in the country. The solution chosen is the Ken-Betwa Link. The Ken River is considered relatively water surplus. The Betwa, which serves the drier parts of Bundelkhand, is chronically short. The project transfers surplus water from the Ken to the Betwa. The scale of the promised benefits explains the political weight behind it. The project is designed to irrigate 10.62 lakh hectares, over 1 million hectares, of drought-prone farmland. It aims to provide drinking water to 62 lakh people, more than 6 million across 13 districts, and to generate 103 megawatts of hydropower, plus 27 megawatts of solar. For a region that has watched its people leave for lack of water, this is transformational, which is why, despite everything standing in its way, India decided to build it. At the heart of the project is the Dowden Dam. Built across the Ken River, the dam is 77 meters high, about a 25-story building, and over 2 kilometers long. It creates a reservoir capable of storing 2,853 million cubic meters of water, enough to fill more than 1 million Olympic swimming pools. From this reservoir, the water begins its journey to the Betwa Basin. That journey runs through a 221-kilometer link canal, the spine of the entire project, carrying water across the natural divide between the two river systems. To get the water through the terrain, engineers are also building 2 tunnels, one at an upper level and one lower, to move water between levels where an open canal cannot go. 2 powerhouses will generate electricity from the water as it moves, one at the base of the dam, another at a tunnel outlet. The project is being executed in 2 phases. Phase 1 centers on the Dowden Dam, the tunnels, the powerhouses, and the Link Canal. Phase 2 adds further structures downstream, the Lower Ore Project, the Kotha Barrage, and the Bina Complex to distribute the water across the wider region. And after decades on paper, it is now genuinely under construction. The foundation stone was laid in December 2024. Through 2025, site preparation scaled up, and in February 2026, foundation excavation and river diversion work began on the Ken. The dam construction contract has been awarded, and the concrete is finally rising. The whole scheme is targeted for completion in 8 years, but the engineering was never the most contested part of this project. The Dowden Dam sits inside the Panna Tiger Reserve, one of India's conservation success stories, where the tiger population was rebuilt from near zero after poaching wiped it out. And the dam's reservoir will put a large part of it underwater. Around 6,000 hectares of the reserve, nearly 10% of its core and buffer areas, will be submerged or diverted for the project. That threatens core tiger habitat, the gharials of the Ken Gharial Sanctuary, and the nesting sites of vultures. Estimates for the number of trees to be felled range from 2.3 million to as many as 6 million. The Supreme Court's own Central Empowered Committee had earlier flagged concerns about irreversible damage to one of central India's most important protected ecosystems. There is a human cost, too. The project requires relocating around 2,000 families who must rebuild their lives elsewhere through a slow and complex rehabilitation process. And that process is not going quietly. Through 2026, protests over displacement and compensation have grown in the villages facing submergence. And some scientists question the core premise. The entire project rests on the assumption that the Ken River has a reliable surplus to give. Independent hydrologists have warned that this surplus may be overstated. In a changing climate with increasingly erratic monsoons, the extra water the Betwa is counting on may not always be there. If the surplus fails to materialize, the project could disrupt downstream flows without delivering the promised benefits. This is the central tension of the entire river linking dream. The engineering is achievable, the benefits are real, but every link means damming a river, flooding a forest, and betting that the water will keep flowing the way the models predict. The Ken-Betwa link is only the first. It is the opening move in a plan that envisions dozens of similar links across India. A national grid for water connecting surplus basins to deficit ones. That is precisely why it matters so much. Ken-Betwa is the test case. If it delivers water to Bundelkhand without the ecological and social damage overwhelming the benefits, it becomes the proof that unlocks the rest. The template for reshaping how water moves across India. If it fails, if the Tiger Reserve is lost, the families are displaced, and the promised surplus never fully arrives, it becomes the cautionary tale that keeps the larger dream on paper for another generation. For over a century, India imagined connecting its rivers. It has finally started in a drought-stricken region that desperately needs the water, at the cost of a forest that took decades to protect. The dam is rising, the river is being diverted, and India is about to find out whether its oldest water dream is a solution or a mistake it cannot undo.